Hello. I'm going to be going over some examples of dynamic memory in C++. This topic is kind of the reason that we have to suffer all the way through pointers, because a lot of things that you might want to do with the computer involve you not allocating memory before the program runs, but rather while it is in operation. And really the only way to do so is with dynamic memory allocation, which relies on us having pointers to places in memory. So with this first little exercise, we're going to write a program that initializes a normal double variable and another one that dynamically allocates a double variable using a pointer. And we'll assign some values and look at what the behavior is like in Python Tutor. So without further ado, let's delve into Python Tutor. That's a demo. I want the actual thing, please. Oh, scroll down to compile my own code. Yes, okay. I think they changed the interface on me recently. So let's copy our exercise. So I don't have to go back and forth. Wish this word wrapped. I don't know why it doesn't. Okay. Initialize a double. So double, my double. Another one is double pointer, my double pointer equals new double. Just drawing a little bit of attention to this line here. If we're dynamically allocating, meaning we're putting memory in the heap instead of the stack, we need to use the new keyword to tell the computer that's what we mean. And since this is something that we can eventually delete if we want to, we need to have a pointer that's going to reference that place in memory. So now I can assign values to these. My double is 3.14, and my double pointer, the value at that is equal to, let's say, 1.5. Then I can delete my double pointer. Forgot the P here. And delete it when I'm done. So let's take a look at what this looks like. Really with pointers, I find the best way to understand what the heck the computer is doing is to actually run it step by step in something like Python Tutor so we can see what's happening. Now, in the computer, before I've done anything, the code hasn't actually executed yet. I'm at the beginning of this main function. The first thing that happens is space is allocated for a double variable and a pointer to a double variable. But the actual thing that my DBL PTR is going to point to hasn't been created until I run line 7. I want to really dig in here to memory addresses. This is really tiny. So you can see triple F, triple O, BDO, triple F, triple O, BC8. These are pretty close to each other in memory. But when I run line 7, you can see here's a completely different spot in the computer that indicates the address of where the actual double variable is. And this pointer is going to refer to that space in memory, which is where there is just enough room for a single value that's going to be 1.5. When I assign my double 3.14, the value inside of here changes to exactly that. When I assign what's at the pointer 1.5, the data is modified inside the heap. And if you don't want to have memory leaks, it's generally a good idea to make sure that you delete any data inside the heap that you don't need access to. So delete my DBL PTR goes away. Boop, and it's gone. Note there's a little skull here, and the Python Tutor just uses that to indicate that a pointer points to somewhere in memory that's no longer been allocated. So you should not try to access something after you've deleted it, because who knows what could happen. Okay. All right. Dynamic arrays. So we've made dynamic variable. Let's try dynamic array. I'm going to ask the user for a number. We're going to create an array with that many strings in it and ask the user to write words for that array and then print them out. So let's go into our little environment. Let's go into videos. I do not remember what week this is. I'm going to say it's week 9, but maybe that's wrong. I think it's the right week. We're going to find out, I suppose. And let's make a new file. This is exercise2.cpp. Oh, did that not go? There we go. Okay. Prompt the user for a number, make an array that has that many strings, ask the user to write words to fill it out, then print them in order. Okay, zoom in a bit. We need our usual suspects. Okay, prompt the user for a number. So the first thing I should do is definitely say, please give me a number. So that will be the size of our dynamic array that we're going to make. I'm going to read that in. And now I need to dynamically create an array that contains that many strings. So I need strings, a string pointer, my strings, and it's going to point to a new string array that's going to have size strings inside of it. I always forget if this is valid syntax, so before I go any further, I want to make sure I can compile this, because if I can't, then I made a typo. So, terminal, compile this code. Everything seems okay for now. And if there's something wrong, I'll figure it out later, I suppose. Okay, so now I have dynamically an array that happens to have however many strings they have said that they can make, and I'm going to ask the user to write words to fill that array. Okay, so I need to make a for loop. It's going to go once for every word in the array. And I'm going to ask them now to put words in to fill the array. So we'll say, please give me a word. We're going to have string word. We're going to read in their word. I suppose I don't actually need another variable for this, but it's okay. And then we're going to make my strings of I be the word. I could save a step without, and just directly put this here if you want. So maybe I'll do that as well, just to show. Another option is simply cin, take what they enter and put it into my strings I. Okay, so now they've given me a bunch of words inside my array. Now I want to print those words out in order. So I can make another loop, and this time I'm just going to output my strings with an endline character. Okay, let's try it out. Compile, run. Please give me a number. Let's say we want 5 strings. Hello. So this is pretty ugly, right? We got like, a prompt followed by just immediately user input. We can do a little better. So I'm going to Control C to get out of that. And so please give me a word, colon, new line, and that way they actually put stuff on a new line. Same thing here. Make it a little nicer looking. Presentation is important. Okay, compile, run again. Please give me a number. 5, give me a word. Hello, my name is Michael. Hello, my name is Michael. Boom. And so the sort of the nice thing about doing something like this is now we can say that we actually have an array where the size of the array doesn't need to be known before I run the program. This array here, my strings, is set up in the heap, and the amount of space that's allocated for it is entirely dependent on the number that the user actually typed in. It means I don't have to worry about setting aside 100 megabytes worth of space. I only need to set aside exactly as much space that is there. Now, one last thing I should do to be very good practice is to delete my strings. Typically, if you don't do this, it's not going to cause your computer to explode or anything, but it is a good practice to do so because many times you will end up writing a function where perhaps it's the case that this function gets called many, many, many times. And if you don't deallocate the memory associated here in the heap, your computer will keep making more and more memory allocated for your program that you may not actually be using anymore. Once you are done with an array that you've allocated dynamically, it is the best thing to do to delete it as soon as you're done with it. And this doesn't affect the code, how it runs whatsoever. Okay. All right. Resizing an array. So this is a pretty common problem where you have an array of one size and you want to transfer over information into another array. So let's grab the problem here. And we're going to make another exercise. I think I'll actually duplicate this one just to save myself a bit of typing time. And I'll get rid of everything except for the boilerplate, and I'll replace the comment here with the other problem. Okay. Make a dynamic array that contains 5 strings. Let's pause there and let's just do that. It shouldn't be too hard. We need to make a string pointer that's going to point to my array, and it's going to have 5 strings. Okay, that's not too bad. Ask the user for words and put them in the array until they type stop. Okay, so string input equals nothing, and while their input does not equal stop, we're going to ask them for words and put them in the array. Now, where in the array are they going to go? Well, I want to start out with position 0, and then 1, then 2, then 3, then 4, and then at some point the array is going to get full, and I'll have to figure out how to deal with that. But first things first, I want to at least be able to put words in the array in ascending order. So we're going to need a current index, which is going to be the start at 0, and every time we add in a new word, we'll increase it. So as long as the input's not equal stop, we're going to say, please enter a word, stop to stop. Yep. We're going to, we can do get line here is fine. And we're going to put that into input. So now they've entered a word, and we're going to set my array of the current index to be what they just typed in. And finally, our current index will go up by 1. So what this will allow me to do is put in at least 5 strings. Now, I want to also make sure this actually worked, so I'm going to write in a little bit of extra code here to actually print out the array so I can see what's happening. So for I 0, I is less than 5, I plus plus, print out, I think I'll have to use cout for this because it's a string, my array of I, and a new line. Again, let's make sure this compiles, because if it doesn't, that's another problem to deal with. Compile exercise 3. Seems okay. Please enter a word. Hello, my name, stop. Okay, so a few things is first off, it's putting stop in the array. That I might want to fix. And second of all, otherwise I think it did everything mostly okay. So I do want to fix the issue of putting in stop at the end. That's not something I really want. So let's see if there's a way around that. Probably there's a couple ways. Maybe I can restructure the code. I'm going to take kind of the lazy approach here, but you can maybe figure out a cleaner way to do this, which is that if the we'll get their input, and then if their input is not equal to stop, then I will do all this other stuff. A little sloppy, but there are perhaps better ways that you can do this. That I'm kind of just taking the quickest approach right now. So this stops when I ask it to stop. It prints out everything in my array, but I haven't quite finished the problem, which is that when the array is full, I need to make a new array that fits 5 more strings, add all the words entered so far to it, then delete the original array. So there's a couple steps I'm going to need to take here. First of all, it's not necessarily the case that my string is always going to have 5 elements in it. So I want to keep track of the size. And it's going to start as 5, but it's going to change over time. So initially, there's going to be space for 5 strings. And now, every time the current index goes up, I need to consider, has the current index reached the size of my array? And if so, then I need to do something. So if the current index is now equal to the size. So let's say that I've entered in 5 words, and now I need to enter in more. Then what I'm going to have to do is a few things. And so let's kind of break down the steps. So my goal is to make a new dynamic array, transfer over all the data, and delete the original. If you don't delete the original, this can cause memory issues very, very quickly as you keep allocating more and more increasing amounts of memory that don't get freed up. So we're going to make sure we do all of these things. So first step is to make a new dynamic array. So string star new array is going to be a new string array, and it's going to have a size plus 5 because we're making space for more strings to go in here. I gotta transfer over all the data. Okay, so for each element, I less than size, I plus plus, in my old array, the element at new array I, actually no, I can just do new array I, yeah, is my old array I. I'm just directly copying over everything that's there. Now, there's a few things I need to do. First of all, I need to delete my original array. So delete with brackets my array. I've transferred over all the information from my array, so I don't need it anymore. I can delete it. But all my code depends on the thing that I'm actually putting data into being called my array. So if I want to make it so my array refers to this new one, my array is going to be the new array. Remember, both of these are pointers, so when I make this equation, I'm just telling the computer, hey, my array should point to this new one that I just made. I'm not actually modifying anything otherwise in the computer. And then finally, the size is no longer this size, it's now size plus 5. So size is size plus 5. And finally, to print everything out, I don't want to print out just 5 things. I want to print out however many I ended up with at the end. So let's see if this works if I have more than 5 words. And if so, then I've done it correctly. Okay, and hello, my name is Michael, and I am a professor at Ontario Tech U. Stop. And look at that. Hello, my name is Michael, and I am a professor at Ontario Tech U. Stop does not appear in here, which is nice. And also, if you look at how many, it happened to print out exactly as many as I did, although I think conveniently I may have put in just enough to make this look nice. It looks like it prints out exactly as many times as there is space in the array, which right now I believe is 15. 5, 10, and then these 5 lines are 15. So that's why there's an extra little space down here, because this space in the array right now happens to be empty. Not always the case that it is, so you may want to be a little careful about that kind of thing. But that's okay. I think for now, this at least accomplishes the main thing we were looking to do, which is use dynamic arrays where we can resize them, modify our pointers and so on, and even if I decided I wanted to make 100 words, my program would still be able to handle that without any issues of memory leaking. Okay. Right, last exercise. Continuing from the previous exercise, prompt the user to enter a word from the array. Create a new dynamic array that has all the words from the array except the one they just entered, and delete the old one. Okay. So let's make a duplicate. This will be exercise 4. Prompt the user to enter a word from the array, create a new one that has all the words from the array except the one they just entered, and delete the old one. Okay, so we'll take a little bit of a assumption here in that we'll assume the array has no duplicate words. If it does, this may not work quite as much as we like, but otherwise the main thing here is being able to, again, make new dynamic arrays that have the right information. So now that we've done all this, we can prompt the user to and actually, I'll move this comment down below to where I'm actually working, which is down here. Okay. Prompt the user to enter a word from the array. and we'll ask them for a word. I believe I still have an input variable from before, so I'll use that. Now I need to make a new dynamic array that has all the words from the array except the one they just entered, and then delete the old one. I'll also, I think, assume here that the word is actually in the array. If it's not, I would need to account for that, but we're going to keep it simple here and just assume they typed in something valid. So they've typed in a word that appears once in the old array. Now I want to make a new one that has all the words from the array except that one and delete it. So I'm going to need a new array. So again, string star new array. Remember, because this is outside of this loop, where is it? This loop where a new array has been declared. This is a brand new variable that hasn't been used yet. And it's going to be a new string array where the size is size -1. That one word is going to not be in there. Now, I need to transfer over all the words from the array except the one they just entered. So this is a little bit, I'd be very careful about this because it means that it's possible that the first word in my old array is the one they entered, in which case I don't want to copy that over, I want to copy over everything else. Which means I'm actually going to need a couple variables. I think I'm going to have a variable called int, I guess we'll call it new array iterator, and it's going to start at 0. And my goal here is to make it so that I can take each word from the old array and put it in the new array in the right spot. I don't want to be skipping over what's there. So here's kind of what that's going to look like. I do want to write my for loop the same way I'm used to because it's convenient. So for every word in my old array, if that word is not equal to the input, I want to put that in. So then, new array of this new array iterator that I made is going to be my array I, and my new array iterator will go up by 1. So let's say that the word that I'm looking for, that I don't want to include at the very end. Then the first time this loop goes, I is 0, new array iterator is also 0, so my new array first element is my old array first element. And then both of them are going to go up because I have I++ and I have new array iterator ++. So the second time, my array 1 gets assigned for new array 1, and so on. And at one point, I'm going to run into a place where my array has the input. And here what I want to do is I do want to skip over that, but I don't want to change where I'm putting things in my new array. I want my new array to have all of the elements all next to each other without any gaps. So I'm not going to increment my new array iterator if I happen to have found that they match. So else I do nothing. Now, if I've done this correctly, my new array will have all of the data that I'm there, and my new size is going to be size -1. I want to delete my old array. And then once again, I want my array to point to the new array. And then finally, I want to print out what's in it, using the same code from before. Okay. So, hi, my name is Michael, and I am a CS prof. Stop. Okay, something has messed up because I didn't get the second part of my code to go. Oh, it's because I compiled the wrong program. This one. There we go. Let's try that again. Hi, my name is Michael, and I am a CS prof. Stop. Okay, so here's my array. And I want to enter a word from the array. In this case, I'm going to go to, let's go with name. So instead it will say, hi, my is Michael, and I am a CS prof. We'll get rid of the name. Hi, my is Michael, and I am a CS prof. It's really important to make sure that you don't forget any of the steps that are in here, namely deleting the old array so that you don't have any memory issues. Here, the trick is to actually have 2 variables for iterating through the arrays, because you're going to have one to keep track of what's in the new array and want to keep track of what's in the old array, and you don't want to be accidentally mixing them up or skipping over something in your new array. The new array should have everything all tightly packed and not have any gaps in there, which is what we ended up being able to get going. And by making the adjustment to the size and to change the pointer back to point to the new array, now when I run the exact same code I had before, it prints out all the contents just as I like. So that wraps it up for dynamic memory. These are just a few examples of how it gets used. We'll see a lot more of dynamic memory when we start dealing with objects and so on, but this is at least enough to get kind of the basics of the main things that you need to be able to do when it comes to working with pointers and the new operator. So thanks for watching, and I'll see you in class. Bye-bye.